Okay, we're going to be looking at some work we can do with the formulas that we've already seen involving 2 alpha, you may have seen it as 2 theta. So those being sine 2 alpha equals 2 sine alpha cos alpha, so that's one of our double angle formulas as we call it. We've also got cos 2 alpha can be written as 2 cos squared alpha minus 1, also 1 minus 2 sine squared alpha, and it can also be written as cos squared alpha minus sine squared alpha. So sine 2 alpha, our double angle formula for that, which will be given in the formula sheet, is 2 sine alpha cos alpha. Cos 2 alpha can be written either as 2 cos squared alpha, 1 minus 2 sine squared alpha, or cos squared alpha minus sine squared alpha. Okay, now the first exercise that we're going to do is just to prove where these formulas come from. So prove that sine 2 alpha can be written as 2 sine alpha, prove that cos 2 alpha can be written as that, and it can be done fairly easily with a couple of short proofs. Okay, so sine 2 alpha could be written as sine alpha plus alpha. Now what we could do then is use the sine expansion, and the sine expansion is that sine A plus B is equal to sine A cos B plus cos B sine A. So that would be sine alpha cos alpha plus cos alpha sine alpha. Okay, so sine alpha cos alpha and cos alpha sine alpha are the same thing. There's 2 of them, so it's then just 2 sine alpha cos alpha, so that's dead easy, that one. Okay, let's look at proving this one. Okay, so cos 2 alpha could be written as cos alpha plus alpha, so that's cos alpha minus sine alpha sine alpha. I'm just using the addition formulas here, so just a quick reminder that sine A plus B is sine A cos B plus cos A sine B, and also the cos A plus B could be written as cos A cos B minus sine A sine B. So pretty straightforward stuff. And if I just replaced the A and the B with alpha. Okay, so the first one to prove then, actually let's go for that one, that's dead easy. So cos alpha is cos squared alpha, and sine alpha is sine squared alpha. Okay, so there's that one proven now. So next thing that I'm going to do is to prove this one. Okay, now the next thing is, remember that one of my trig identities from National 5 is that sine squared plus cos squared is equal to 1. So what I could do is write that as sine squared is equal to 1 minus cos squared. Or I could write it as cos squared is equal to 1 minus sine squared. Okay, so what I'm going to do next then is I'm going to replace that sine squared with 1 minus cos squared, so that would be cos squared alpha minus 1 minus cos squared alpha. So that would be cos squared alpha minus cos squared alpha is 2 cos squared alpha. And I've got minus 1, and then there's that one. Okay. Alternatively, what I could do is replace cos squared alpha with 1 minus sine squared alpha, so that would be 1 minus sine squared alpha minus sine squared alpha again, which will give me 1 minus 2 sine squared alpha. And there I've proven that one. Okay, so it's just a kind of starting point. Let's try a couple of examples involving some of these formulas. Okay, so let's try an example 1, which is, given that tan theta equals 4 over 3, calculate sine 2 theta and cos 2 theta. Okay, now the first thing to do, as soon as you're given a trig ratio, what you can do immediately then is draw a right angle triangle, which is suggesting that remember SOHCAHTOA, that's the opposite and that's the adjacent, so the opposite then would be 4 and the adjacent would be 3. Now using Pythagoras then we know that the longest side, the hypotenuse, would be 5 and the angle down here is theta. Okay, so what I can then do is that then opens up my ability to find other trig relationships. So sine 2 theta is equal to 2 sine theta cos theta. So sine 2 theta is equal to 2 lots of sine theta. Well, sine theta then, this theta is going to be opposite over hypotenuse, that's 4 over 5, multiplied by cos theta, which is going to be the adjacent over the hypotenuse, 3 over 5. Okay, so if then get 2 times 4 is 8, 8 times 3 is 24, over 5 5s are 25, 24 over 25. Okay, so sine 2 theta, I've just proven then that can be written as 24/25. The key thing is, as soon as I'm given a trig ratio from SOHCAHTOA, that allows me then to draw a right angle triangle, get the third side through Pythagoras, and then that opens up the other ratios to calculate. Okay, so I'm now going to calculate cos 2 theta. Now, to calculate cos 2 theta, well, I've got 3 options here. I could use this one, or this one. Now, you only need to do it once, but in this occasion, just to show you, I'm going to prove it 3 times using 3 different formulas. So the first one that I'm going to use is I'm going to prove it with 2 cos squared theta minus 1. Okay, so that will be 2 multiplied by, what was cos theta again? That's adjacent over hypotenuse. 2 times 3 over 5 all squared minus 1. So that's 2 times square top square bottom. 2 times 9 over 25 minus 1. So that's 18 over 25 minus 1. 18 25ths, take away 25 25ths, and that is minus 7 25ths. Okay, let's prove it using the second one, which was 1 minus 2 sine squared. So cos 2 theta can be written as 1 minus 2 sine squared theta. So it's 1 minus 2 lots of sine theta, so that's going to be opposite over hypotenuse, 4 over 5 all squared. Okay, so that's 1 minus 2 lots of 16 over 25. That's 1 minus 32 over 25, which is 25 25ths minus 32 25ths, which will give me the same answer again, minus 7 over 25, minus 7 25ths. Okay, so I'm going to prove it another time, and this time I'm going to prove it finally using this one, which was cos squared minus sine squared. So cos 2 theta can be written as cos squared theta minus sine squared theta. Okay, so cos theta, again, that's 3 over 5, so that's 3 over 5 squared, minus sine theta, sine squared theta, so that's 4 over 5 squared. Okay, square top and bottom, 9 over 25 minus 16 over 25, which gives me the same result again, minus 7 over 25. And the key thing there is you only need to prove it once. I've just shown you as a kind of case example that it's worked using the 3 different formulas because they're all applicable for cos 2 theta. Okay, next one, we're going to find an expression for sine 8 theta and for cos 8 theta. Okay. Now, key thing is, let's think about the double angle. Sine 2 theta equals 2 sine theta cos theta. The key thing to see there is whatever angle is here, you half that angle here, right? So whatever that angle is there, that's the double angle, you half it there. So 2 theta becomes theta, that becomes theta there, right? So the key thing is you take this angle here and you half it. No matter what the angle is here, you half it. Now if the angle in there is 8 theta, that's pretty straightforward then. Sine 8 theta is going to be 2 sine 4 theta cos 4 theta. So I've just followed that advice. I've halved that angle. It's a double angle which gets halved. Half 2 theta to get theta, half 8 theta to get 4 theta. Okay, and for cos 8 theta, well, I've got some options here, so I'll just choose one. So let's go for cos 2 theta is equal to cos squared theta minus sine squared theta. Okay, so again, what happens is the double angle gets halved. 2 theta becomes theta. Okay, which means that 8 theta becomes 4 theta. So it's going to be cos squared 4 theta minus sine squared 4 theta. Key thing to remember is that the angle gets halved. The angle gets halved. Okay, next one, we're going to find the exact value of 2 cos squared 15 minus 1. Okay, now if you think about 2 cos squared 15 minus 1, that should put you in mind of 2 cos squared theta minus 1, which is equal to cos 2 theta. Now the key thing being to get back to the double angle, right, so you've got 2 cos squared theta minus 1. To get back to the double angle formula, what you need to do is double that angle. Okay, so that theta gets doubled to be cos 2 theta. Well, in the same way then, 2 cos squared 15 minus 1, that 15 would doubled to give you cos 30, and then cos 30 you just lift that from your exact values. Dead straightforward, that's root 3 over 2. Okay, let's try another one, which is going to be find the exact value of 2 sine 15 cos 15. That should put you in mind of 2 sine x cos x, or 2 sine theta cos theta, or 2 sine alpha cos alpha. In any case, that is your double angle sine. So that gives you sine 2x. So what happens here is the x gets doubled, the angle gets doubled, the angle gets doubled to give you sine 30, and sine 30 again, lift it from your exact values, is 1/2. Okay, let's try another one. Given that cos x equals 12 over 13, find sine 2x. Okay, so what was the advice I gave you earlier on? If you've got a trig ratio, the first thing that you can do is you can draw a right angle triangle. So that's adjacent over hypotenuse. So the adjacent is 12, the hypotenuse is 13, which means that you can now find the third side. So let's find that out. Let's call it x. X squared equals 13 squared minus 12 squared. X squared equals 169 minus 144. X squared equals 25, and x is equal to square root of 25, which is 5. Now that triangle's not particularly accurate, it's not drawn to scale, but we'll go with it. Okay, so sine 2x then is 2 sine x cos x. So it's 2 times sine x, so that's opposite over hypotenuse, 5 over 13, multiplied by cos x, which is adjacent over hypotenuse, 12 over 13. 2 times 5 is 10, 10 times 12 is 120, and that's 120 over 13 times 13 is 169. Check if it can be simplified, which it can. Okay, let's try one more problem. Okay, we've got a circle. Inside the circle we've got a kite. And we're told that this bit's x, o, and y. We're told that that side is root 5, and that's 3. Since it's a kite, then that's information I've been provided with, but I can immediately say since it's a kite that that'll be 3, and that's also root 5. Okay, so the first question then says, well, the question does say, find sine x o y. Okay, x o y, so I want to find this angle here, sine of that angle. Okay, some laws of circles are going to come into play here. If I put a diameter down here, now that will be a right angle triangle. Now why do I know that? That's because this is a wee bit of National 5, even National 4 knowledge. If you've got a semicircle and identify any spot on the circle and draw a triangle in there, that is always a right angle triangle. So I know that that's definitely right angled. What I can do next then is I can calculate the hypotenuse using Pythagoras. So let's call it a this time. So a squared equals root 5 squared plus 3 squared. Root 5 squared is 5, 3 squared is 9, so if now get a squared is equal to 14 and a is equal to the square root of 14, that's a third which I can't simplify, so I can throw it straight in. Okay, so sine x o y then. So what I'm going to do next is call that angle alpha, and since this has been split down the middle, I could also call that angle alpha, so that's going to be, what size is that angle there then? It's alpha plus alpha, that's sine 2 alpha, which now means I can bring in my double angle formula. That can now be written as 2 sine alpha cos alpha. So that's 2 times sine alpha, so there's alpha, so that's opposite over hypotenuse, root 5 over root 14, multiplied by cos alpha, which is adjacent over hypotenuse, 3 over root 14. 2 times root 5 times 3, well 2 times 3 is 6, that's 6 root 5 over root 14 times root 14 is 14. I can now simplify 6 over 14, top and bottom by 2 then. We'll bring that down to 3 root 5 over 7, final answer.